All right, the next two examples, if you read them, number 4 is talking about from T to C. So if we label this, I'm going to go ahead and put T to C 18x minus 1 and C to V 17x. I'll just leave it like this. They want us to find TV. Now notice here it's not dealing with angles, it's not dealing with the sides. So I have to go back to the theorems. And this one, it's not that easy to prove. Well, I mean, it is actually using congruent triangles. But this one is talking about the diagonals of a parallelogram bisect each other. So basically this theorem tells us if we have a parallelogram, if we draw the diagonals, basically this side is going to be congruent to this piece right here, and this piece is going to be congruent to this piece. Now that's not to say that all of them are the same. Okay? So you could say, for example, U to Q could be 8 and then Q to S is 8, but that doesn't mean R to Q has to be 8. Alright, so let's just highlight, I guess, that one. Diagonals bisect each other. There's the abbreviation and there's the picture. Alright, let's jump back to the example then. Now that we know that the diagonals are going to bisect each other, that means that this piece right here from T to C should be the same thing as this one right here. So I'm going to go ahead and write that in. The diagonals bisect each other. So I know that TC is congruent to CV. And then just start drawing your equation. If I know that from T to C is 18x minus 1, I'm going to set that equal to 17x. Only because, again, I knew that the diagonals bisected each other. And then just, again, the rest is just algebra. Solve for x. This is 0, so you're left with 18x is equal to 17x plus 1 minus 17x minus 17x. 18 minus 17 is 1x, so you're just left with x is equivalent. This goes to 0, 1. Okay. Now x is equal to 1, but again, like the directions indicate, they want us to actually find the measurement from T to V. So they actually want from this point all the way to this point over here. And if I do that, T to V is basically going to be plug in the x into T to C. So if I substitute x equals to 1, 18 times 1 is 18 minus 1. This minus 1 is 17, and 17 times 1 is 17. So once again, TV is going to equal to 17 plus 17. So TV is the same thing as 34 units. Guess I'll put an arrow here that you, once you found the x, make sure that you substitute it back correctly to whatever it is that they're looking for. All right, that was dealing with diagonals. The next example is, let's look at that one. All right, the next example, what am I dealing with? Sides, diagonals, or angles? What are they asking for? Angles. Okay, so just be careful here. In this particular case, I'm going to be dealing with angles. So let's recall our properties. I know that opposite angles are congruent, but here I don't have opposite angles. So you may need to, again, if you forget the properties, of angles, just extend your